Hello, Year 12. Today, very special edition here because it's filmed. Look, you see no Lego stand. We are actually, look at that, we're in the lab. Alright, so there's school. If you remember what that was like. Look, that's where people sit here and there you go. Hello, everybody. So today, I'm in school. I'm talking a bit quieter than normal because I'm a little bit self-conscious doing these videos when other people can hear me. Today I just want to set you up for this week's work, which is on thermodynamic definitions. Now, what I've asked you to do is to learn some thermodynamic definitions and their accompanying equations. In fact, so it's this sheet here, definitions. It's from the booklet. It's in the close your work folder. And you'll notice there is a word definition and there is an example. There's also a column here that tells you whether it's typically an exothermic or an endothermic process. Alright, now some of these definitions you've come across in AS chemistry, Year 12 chemistry. So we've got enthalpy of formation and enthalpy of combustion. So for example, I would expect that you could all define enthalpy of formation. So the enthalpy of formation for a compound is the enthalpy change when 1 mole of a substance is formed from its constituent elements in the standard states. So if somebody, for example, asks you for the enthalpy of formation of sodium oxide, you would say, right, sodium oxide is made of sodium and oxygen. There's the elements in their standard states. Oxygen is a gas, sodium is a solid, sodium oxide is a solid. Because you're forming 1 mole of a compound, you would have to balance with 2 sodiums and half an O2. So there were 2 things to do there. You needed to know the word definition and also be able to write an equation if you were given the compound that's being formed. So another example, if you wanted to form glucose, somebody said, what's the enthalpy of formation, delta HF? For glucose, you would say glucose is a solid. It's formed from carbon, hydrogen, which is H2 in its standard state, and oxygen, O2. You would use 6 carbons, 6 hydrogens, and 3 O2s. You would do solid, gas, gas. That's typically worth 1 mark in an exam, which is brutal, really, isn't it? Because if you miss out one of these state symbols, you're not going to get the mark. Alright, so another one that you know from year 12 is the enthalpy of combustion. So here's the word definition. It's the enthalpy change when 1 mole of a substance is completely burned in oxygen, with all substances in their standard states. So if somebody says, what's the enthalpy of combustion of carbon? You would go carbon, 1 mole of carbon being burned in oxygen will make CO2. That's a gas, that's a gas, that's a solid. What's the enthalpy of combustion of magnesium? You would say magnesium being burned is O2, magnesium oxide. Knowing my ionic charges, magnesium oxide is MgO. So it's burning 1 mole of this, so you would need half an oxygen, and you'd make, magnesium oxide is a solid, that's a gas, that's a solid. If somebody asks you what's the enthalpy of combustion of C2H5SH, you go, what? Well, you go, you're going to burn this. So if you burn this, the carbons will make carbon dioxides, the hydrogens, all 6 of them, will make waters, so there'll be H2Os, and the sulfurs, you need to know, would make SO2s. So then you would go, 2 carbons will make 2 carbon dioxides, 6 hydrogens will make 3 waters, 1 sulfur will make 1 sulfur dioxide. 1, 2, 3, 4, 5, 6, 7, 8, 9 oxygens will be 4.5 O2s. So this is an equation, it's a solid, that represents the enthalpy of combustion of, this is called ethane thiol, I think. Better chemists might put me right on that. I think it's ethane thiol. Right, so anyway, that's enthalpy of combustion. The point is that these 2 are things that you did at year 12 and also in the work last week. Another thermodynamic definition that you know from last year is delta HIE, which is the ionization energy. So there's a word definition for this. It's the enthalpy change when 1 mole of gaseous atoms forms 1 mole of gaseous 1 plus ions. All right, so 1 mole of gaseous atoms forms 1 mole of gaseous 1 plus ions. Battery power is low, 5%. This could go badly wrong. Plus an electron. All right, so that is another one that you've learnt last year. Second ionization energy. Well, if you had the second ionization energy, it suggests it's already been ionized once. So you go X plus, forming X2 plus an electron. So that represents, when you put the state symbols in, the second ionization energy. No state symbols, no mark. So here are some definitions that you know from year 12. So there's another one that you know from year 12, which is bond enthalpy, which is the enthalpy change when 1 mole of covalent bonds is broken in the gaseous state. So here are the definitions you need to know for year 13 for basically for your A level. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but you already know this one, this one, this one, and this one. So you already know 4 of them, which means that you've got 1, 2, 3, 4, 5, 6 more to learn. And that's the job that I'm asking you to do for next week when I see you, or the following week if you're on the second week of visits. I need you to learn all of these word definitions and the symbol equation when asked. All right, just to make sure that you know that topic. Okie dokes. So to help you learn these definitions, we're going to look now at a task. So it's task 3, and it looks like this, and it's followed up by task 4, which is a little bit more challenging. So I'm just going to give you a little bit of an introduction on how to approach these tasks. Now, you don't have to do these from memory. You're allowed to do them using this sheet. And let's hope my battery doesn't die halfway through this. Okay, so for example, here's how I would approach this. The first question asks you for an enthalpy of formation for this. So if it's an enthalpy of formation, if I was a little bit less confident, I go enthalpy of formation, that's when 1 mole of a substance is formed. So you write the substance on this side, C6H6, you remember the state symbols, and you go from the elements in their standard states, where it's made from carbon and hydrogen in the standard states, solid, that's a gas, 6 hydrogen, so you'll need 3 H2s and you'll need 6 of these, that's done. All right, and you can check your answer. The second one is a formation, there's a combustion, there's a combustion. Some people get confused, what happens when you burn oxygen? Well, nothing. So this one, CH3COOH, it's a combustion, so you write plus O2. Then you write the combustion products. When you burn carbon, you make CO2. When you burn hydrogens, you make water. When you burn oxygens, well, you can't burn oxygens. Okay, so 1 carbon, 2 carbons, so you'll make 2 CO2s. 1, 2, 3, 4 hydrogens, so you'll make 2 H2Os. Now, that's going to be a gas. That's going to be a liquid. Oops, I just think. Sorry. Oh, yeah. No, that's right. That's going to be a liquid. CH3COOH, that's a liquid. Tells you on there in the question. Oxygen is a gas. Now, you have to balance it, but you're not allowed to put any numbers in front of this because it's when 1 mole is burned. So I need a number in front of this. 1, 2, 3, 4, 5, 6 oxygens. There are 2 oxygens already here, so you're going to need 2 O2s, for example. 5, 6, and 7 are ionization energies of aluminium. I think that's going to be self-explanatory. Question 8, electron affinity. So there's a new one. The word affinity means if you have an affinity for something, it means you like something. So if I have an affinity for chocolate, I'm probably going to end up eating chocolate. If you have an affinity for electrons, you'll end up taking in electrons. All right? So the electron affinity is the enthalpy change when 1 mole of gaseous atoms gains an electron to form gaseous minus ions. So electron affinity of chlorine, 1 mole of gaseous atoms, I'm reading here, 1 mole of gaseous atoms, so that's 1 mole of gaseous atoms, gains an electron, okay, gains electrons to form 1 mole of gaseous negative ions. Done. All right? Then you've got some other things, lattice enthalpy of formation. So that is down here on your sheet, lattice enthalpy of formation. You need to read this carefully, all right? I'm not going to do no spoilers on this. All right, that is not the same as just enthalpy of formation. It's the lattice enthalpy of formation. It's specifically about giant ionic lattices. It's very, very important that you get your head around that. Lattice enthalpy of dissociation. Formation is when something is formed or made. Dissociate is the opposite of associate. So dissociate means to break apart. So a lattice being broken apart. All right. It actually means a lattice being broken apart into its gaseous ions. So have a look at the definition, look at the example given and try that. Hydration, again, look at the definition, see how it does it on the sheet, and then do it for this. So I hope you get the idea here that you're just looking at these definitions. You've got your sheet, which has got an example and the words, and you can work your way through there and check your answers. Let's just have a little look at any other bits that might be tricky. Bond dissociation enthalpy of water, you'll probably wonder why you've got that one wrong, all right, when you look in the answers. Bond dissociation enthalpy, you've got to think about how many bonds there are. It's referring here to the OH bonds in water. So I'll leave that one there for you to think about. Vaporization isn't one of them on your sheet, but vaporization is when you take a liquid and you turn it into a gas when you vaporize it. So have a little think about that. And it's going to be to do with 1 mole of bromine. Remember that bromine is Br2. Right, task 4, just to give you a little introduction to this. This is where you're given the equation and you're asked to say what it is. Well, this is 1 mole of gaseous atoms forming 1 mole of gaseous 1 plus ions plus an electron. Oh, that looks like A. All right, so you should be able to do this. This is 1 mole of gaseous atoms gaining electrons. Now, if you look here, it's gaining 2 electrons. So when something gains electrons, it looks like an electron affinity. But in both of these examples, this is gaining 1 electron and gaining 2 electrons. So it looks like sulfur gas gaining 1 electron, then gaining another electron to become sulfur 2 minus. What you would write here is, this equation looks like it's a combination of the first and second electron affinities. Now, it won't make that much sense now you're looking at this, but when you look through and get your head around it, that's what that equation means, because it's not the first electron affinity and it's not the second electron affinity. It looks like a mashup of both of these two together. All right, first electron affinity looks like this. Sulfur gas plus an electron makes sulfur minus gas. And the second electron affinity looks like this. S minus gas plus E minus makes S2 minus gas. It looks like a combination of those two. So that's how you would write the answer there. All right, that one's straightforward, that one's straightforward. So if you keep looking through these and trying to find the best description for this, watch out for state symbols. All right, this is referring to an I2 being formed into 2 I's, which is I and I. These I's are gases, these I's are solids. So you might look at this and think, oh, that looks like bond dissociation. But bond dissociation, everything's got to be in the gaseous state. So I'd like you really to be looking up, it looks a bit more like this, solid to gas. Have a look at the answer and see what the answer is for that, okay? So, plenty to be getting on with. I will go through these after on a separate video, but I hope that's a useful introduction to you. You've got to learn these definitions, all right? You have to learn them, all right? There's no two ways about it. I am hot on this. I really, really need you to learn them, all right? Hope you're all right. Please reply to my email to see if you want to do a Teams meeting to go through any of this. I'm thinking probably it's going to be next week going through these definitions. But anyway, we'll see. See you soon. Bye. And I'm just going to give you one last view of the lab. Isn't it nice? It's looking quite tidy, really, isn't it? Right, see you soon.